first lesson on real functions. Today we're going to be more particularly focusing on domain and range. Okay, so with real functions we're going to be talking about the overall properties of different types of functions. And you're probably wondering what I mean by that, but basically that means we're going to be discussing about the relationship between x and y. You know how you have relationships of your own at school, with your families, with your friends? X and Y has its own relationship as well. So I'm going to be discussing how they relate with each other when we get to our examples and questions. Now, with domain and range, that talks about the restrictions that applies to a certain function. So domain talks about the restrictions of the x values, and the range talks about the restrictions that happen with the y values. Okay, but again, I'll talk about those in more depth when we get there. Okay, first of all, let's discuss the different types of functions. There are several of them, so I'll explain to you one by one. And the first one is one-to-one relations, okay? So the first one is one-to-one, and a one-to-one relation exists if for any x value there is only one corresponding y value, and vice versa. So this means, if I explain to you over here, if these represent the x values and these represent the y values, one x value will correspond or pair up with one y value, okay? And vice versa, which means that one y value will correspond to one x value. Okay, that's what it means. So 1 and A are a pair. Okay, so with one-to-one relations, we can talk about pairs working together. So 2 and B are pairs, 3 and C are pairs, and same with 4 and D and 5 and E. Okay, so think about this in your real life situation. I can give you an example such as a husband and wife situation, relationship. So one husband should have one wife, right? And one wife should have one husband. Normally, I hope you guys agree. So one husband, these are the husbands and these are the wife, they should belong to just one at a time, right? That's the relationship they can think about in real life. Now, I'll show you this on a graph. On this particular graph here, one x value, see the x value here, this corresponds to this y value on the graph. So one y value. And this x value corresponds to, again, one y value. And that applies for the negative side as well. So this x value corresponds to this one y value. And same with all the points on this graph. So all the points on this graph, one x value corresponds to one y value. And that's the meaning of one-to-one relation. Okay? Now the next one is one-to-many relations, okay? One-to-many. And a one-to-many relation exists if for any x value there is more than one y value. But for any y value there is only one x value. So again, I'll show you over here. Again, I'm going to let this side be my x values and this side be my y values. So with one x value can have multiple numbers of y values in which it corresponds to. See how there's like 5 of them here corresponding to one x value? But vice versa, on the other hand, one y value, say B, will only correspond to one x value. Okay, so that's the difference. So this x value, can have, doesn't have to have 5, it can have 2, 3, 4, 5 or 6 values of y in which it corresponds to. So if I explain this in a real life situation, think about a classroom where there's a teacher and students. Let's let this side represent the teacher and this side represent the students. So one teacher can have multiple numbers of students in a particular class, right? But one student, let's say student D, can only have one teacher at that particular class or that particular time, isn't it? So that's a relationship you can think about in real life, okay? And again, if I show you this on a graph, this x value here will correspond to this y value, and it will also correspond to this y value, isn't it? So for one x value, there are 2 y values in which it corresponds to, okay? But with this y value, it only has one x value that it corresponds to, and this y value also has just one x value. Okay, so that's the meaning of one-to-many relations, okay? So let's move on to many-to-one relation. So you can think about this as the opposite of one-to-many relation, okay? So a many-to-one relation exists if there is more than one x value for any y value, but for any x value, there is only one y value, okay? So I'll show you what that means over here. Again, the x values, the y values. For any one y value, there can be multiple numbers of x values that it corresponds to. Okay, but on the other hand, for one x value, let's say this one here, 3, this corresponds to only one y value. Can you see that? So that's the meaning of many-to-one. That's the difference with many-to-one and one-to-many. Okay, and again, if I explain this in a real life situation, think about the school that you are attending right now. Let's say this is the school and these are the students that are attending that school. This school can have multiple numbers of students attending that school at a time. But say student 5, this student can only belong to one school at that period of time, at that singular time. Okay, so that's a little relationship you can think about in your real life situation. And again, I'll show you this on a graph. See that y value there? This y value corresponds to this x value, and it also corresponds to this x value as well. So for one y value, there are two x values that it corresponds to on this particular graph, okay? But for this x value, there's only one y value, and for this x value as well, there's only one particular y value that it corresponds to. So that's the meaning of many-to-one relations, okay? So try and think about the difference between the previous ones that I discussed. Okay, now the last relation I'm going to be discussing is many-to-many relations. Okay, many-to-many. And a many-to-many relation exists if there is more than one x value for any y value and vice versa, which means, I'll show you over here, again if this is the x values and these are the y values, x values and y values can have numbers of corresponding values, so multiple numbers of corresponding values you can have. So it can have just one corresponding value like this one here, but whereas look at this x value, it has two corresponding y values. So it can have 3, it can have 4, and vice versa. So there is no particular rule that applies to this one. It can have as many corresponding values as they want. Okay. So think about Facebook, in which a lot of you guys may be using right now. Facebook allows everyone over the world to interact with each other, right? So let's let this side represent the people in Australia, and let's let this side be the people in America, maybe. Okay, so people in Australia can have friends in America and interact with each other through Facebook, right? And this single person can have 2 friends or several friends, whereas the other friend may have 1 friend or 5 friends, 10 friends. So you can have, doesn't really matter the direction, it can have many numbers of corresponding values, okay? Or in this case, many numbers of friends, okay, as they want through the use of Facebook. Okay, so that's a little real life application you can think of. Now, if I show you this on a graph, have a look at this circle here. See for this y value, this one y value, it has an x value here that it corresponds to, and also has another x value here. So for one particular y value, it can have 2 x values, okay? Now think about it this way. See for here, that x value there, for that x value, it has a y value there, and it also pairs up with a y value there. So this time, with one x value, there are 2 y values, okay? So that's the meaning of many-to-many, okay? So y values, both y values and x values can have multiple corresponding values, okay? That's what many-to-many relation is. So I hope those are clear to understand, because now I'm going to be looking at some functions. Okay, now that we've done relations, I'm going to talk about functions, and basically functions are parts of relations. So not all relations are functions, but all functions are considered as relations. But I'll talk to you about that here. Relations which are one-to-one, remember that one, or many-to-one, okay, are called functions. Okay, so just those 2 particular relations, we consider them as functions. So that is, a function is a relation where for any x value, there is only one y value. Okay, and a typical example is one of these straight line graphs. Okay, this is a linear one, and this is a function because for any x value, let's say that point there, there is only one y value there, isn't it? And for any other point on the graph, there's only one y value for any point. Okay, that's why this graph is an example of a function. Okay, now I'll talk to you about this vertical line test, which is used to determine if a relation is a function or not. So a function is determined from a graph. So usually we like to draw a graph and then use my vertical line test. If a vertical line drawn anywhere on the graph cannot intersect with the curve more than once. Okay, so if I draw a vertical line on a graph that I've drawn, I can test if that's a function or not by checking if the line cuts the curve more than once. So if it cuts more than once, it's not a function. But if it just cuts once, it is a function. Okay, so if it's more than once, we can't say that that's a function. So for this graph here, let's draw a vertical line. Let's draw some vertical lines on any point on the graph to check if it's a function or not. So I'm going to put a vertical line there, and you can see that there's one point of intersection. Okay, I'll draw another vertical line over here. Okay, again, there's only one point of intersection. Another one here, one point, and another one here, and it also has one point of intersection, right? So all four has just one point of intersection. So now you can see that wherever we put that vertical line, there will only be one point of intersection. Therefore, it is a function. Okay? If it touched it more than once, that means it's not a function. But in this case, it is. I'll look at another example. Look at example 5. This is an upside down parabola. Again, I'm going to put some vertical lines. So the first one was put there, and you can see there's only one point of intersection. Another one here, there's again just one point. Another one here, 1 point. Okay, another one there, 1 point. So you can see now that wherever I put that vertical line, I'm only going to have one point of intersection, which means, again, this is also a function. Okay, so hope you get that now. That's what we use a vertical line test for, to check if it's a function or not. Okay, so how about we move on to some questions. Okay, question 1 says, state whether or not each of the relations are functions. Okay, so this is a ordered pairs they give us. So I'm going to try to plot these onto our graph and use my vertical line test that I've just described. I'm going to use that to see if that's a function or not. So let's plot these in. So plotting, I don't really worry about that. That should be easy for you guys. So plot those points in like that. Okay, and I'm going to now perform a vertical line test. Okay, just as I explained previously. So on each of these points, I'm going to use a vertical line test. So I'm going to put a vertical line there, and I can see that there's just one point of intersection there. Let's put a point on the next one. Let's put a line on the next one. There's again just one point of intersection, and there, 1 point, there, 1 point. So all these points just have one point of intersection with that vertical line. Therefore, the relation passes the vertical line test. So it is a function. Okay, so that's how vertical line test is used. So now with B, I'm going to put those points into my graph again. So plot them in. Just be careful when you're plotting them. Just be a bit accurate. Okay, now I've done that, I'm going to again perform my vertical line test. Okay, so let's plot a vertical line there first. Okay, put a vertical line there. Can you see that this time there's 2 points of intersection with the vertical line? And as soon as you see that, you can say that the relation does not pass the vertical line test because it intersects more than once with the vertical line. Therefore, it's not a function. Okay? If it touches more than once, it's not a function. So you don't have to even bother putting lines through here because you know straight away that this is not a function. Okay? So that was B. Now with C, again, plot your points in. Just be careful you don't get mixed up with your X and Y's. Now let's plot them in. Okay, so I plotted them on like that. And now again, I'm going to perform my vertical line test. So let's put a vertical line through that place first. And again, can you see that vertical line again has 2 points of intersection? there's 2 points of intersection, which means you don't have to bother putting lines through here, these are the points, because you can see straight away the relation does not pass the vertical line test since it has 2 intersections, therefore it is not a function. Okay, so this one again is not a function. Alright, so that was 1C. Now let's have a look at D. Okay, well I can see that all the y values are 2. So probably the points are going to be like a horizontal way, so like this, yeah? So it's all going to be here. So again, I'm going to use my vertical line test. Let's put the lines in, there. Okay, I can see that there's 1 point of intersection. So let's try the next one. Again, 1 point, and you can now see that this one, 1 point, this one also has 1 point. So all points with the line have 1 point of intersection. Therefore, hopefully you can say now that the relation does pass the vertical line test, so it is a function. Okay, so it is a function as there's only 1 point of intersection on any point. Okay, so that was determining if whether these ordered pairs are functions or not. Okay, so I hope the vertical line test makes sense now. Okay, now we're on to question 2, and question 2a. Okay, this, you can see the graph. It says state whether or not each of the relations are functions. So again, we're going to test if this relation is a function or not. But this time they give us the graph, don't they? So all I need to do is put a vertical line. Okay, use my vertical line test again. And because they have the graph, it's quite easy. I'll just put the vertical line through it and have a look at it. Have a look at the intersections. You can see there's one intersection there and another one there. So there are 2 points of intersection, which means that it does not pass the vertical line test, therefore it's not a function. Okay, so when they give you the graph, all you need to do is put a vertical line, just drop it in there, and then see if there's more than one intersection. But because there's 2, this one is not a function. Okay, so let's have a look at B. This is a parabola. Again, I'm going to put a vertical line there. Okay. And you can clearly see there's only 1 point of intersection, isn't there? So therefore, it is a function. Okay, and you can see that wherever else we put a vertical line, there'll only be 1 intersection, right? So therefore, it is a function. Okay, so that was question 2b. Now, let's move on to question 3. This time, they don't give us the graph. We have to draw our own graph. So graph sketching is a crucial skill that you have to keep, okay? So trying to be good at your graph sketching, because otherwise you might end up with the wrong answer. So with A, it's y squared equals to x, okay? Y equals to x squared is a normal parabola, but remember, if it's x equals to y squared, it's a sideways parabola, right? So it's this kind of parabola. Now, I'm going to simply do my vertical line test and see about, look at the intersections. So there's 1 there, there's 1 there, there's 2, so therefore it is not a function, okay? If it has 2, it's not a function. So this one is not a function, and be careful when you're sketching the graph. Okay, let's have a look at B. Y equals to 2x plus 1. This is just a linear graph, so you guys should be experts on this. Just find your x and y intercepts and join them, and you should get something like this. Okay, and again, let's draw a vertical line. There's only 1 point of intersection there, right? So therefore, it is a function. So that was quite a simple one. And you know that wherever else I put that vertical line, there's only going to have 1 intersection, right? So this one is a function. Now C, x squared plus y squared equals to 9. And you know that 9 is 3 squared, right? So you know that this is x squared plus y squared equals 3 squared. It's going to be a circle with radius 3, right? So it's going to look like this. And you may like to label them, okay, if it asks you to sketch the graph. So labeling is important as well. So label them in like that, and then drop your vertical line. And you can see that there's 2 points of intersection. So again, you can say that this is not a function. This is not a function since it has 2 points of intersection. Okay, and again, you can see that wherever else I put a intersect, there's going to be 2, isn't there? Okay, there's going to be 2 intersections on other points as well, so it's definitely not a function. Okay, now let's look at D. Is y equals to negative root 9 minus x squared, and you're probably wondering what kind of graph this is. If you'd like to see exactly, how about let's how about we square both sides and try to eliminate that square root and see what that ends up with. So if I square both sides, I'm going to get, this will just be y squared. Anything negative that we square becomes positive, isn't it? So I'm going to eliminate that negative and make it a positive. And square root and a square, they cancel each other, don't they? So we're just left with 9 minus x squared on our right hand side, okay? And if I rearrange that, I'm going to have x squared plus y squared equals to 9. And again, this is what 9 is 3 squared. And you're probably thinking that this is exactly the same thing as the previous question, C, but actually it's not. An important thing you got to think about here is you have to look back at the original equation. The original equation has a square root sign, doesn't it? And when you get that, you have to be very careful because a positive root 9 minus x squared is a semicircle above the x-axis. So that's something that looks like this. Okay, sorry about my crooked graph, but that's what the semicircle above the x-axis mean, okay? So if it's a positive that, it means it's above the x-axis, but this one is a negative. A negative root 9 minus x squared represents a semicircle below the x-axis that looks something like that, okay? I'll rub off this one, that one, okay? So it's it's a semicircle below the x-axis only. Okay, that's what you're going to be careful of. So if you draw a full semicircle, a full circle, that's going to be incorrect. So now I'm going to put my vertical line there. So can you see, what is it this time? Is it going to be a function or not? This time there's only one point of intersection, therefore it is a function. Okay, whereas the previous one was not a function. Okay, so please think about the original equation, although you're trying to eliminate the square root or transform it into a normal looking equation. Okay, so that was a function. Now let's look at E. Y equals to x cubed minus x. This time what I'm going to do is try to look for the common factor and then factorize it. So I'm going to have x and then x squared minus 1 inside the bracket. Factorize further by going x plus 1, x minus 1. Right, that becomes that. Now, I can say that my x-intercepts are -1, 0, and 1, right? 0, -1, and 1, yeah? If I let this be equal to 0. So these are the x-intercepts. Plot those in and then join them. And you can see that this is a positive graph, isn't it? The leading term, which is x cubed, has a positive outside. So it's going to be a positive graph which goes upwards on our right-hand side. So this one will look something like this. It's a cubic because the leading term is a power of 3. So it's going to be a cubic that looks like this. So now that we've got the graph, let's put our vertical line. And you can clearly see that there's only one point of intersection, so it is a function. Okay, so this one is a function. And you know that wherever else we put the vertical line, there's only going to be one point of intersection. So this one's a function. Now let's go on to F. Y equals to 1. Okay, y equals to 1. This one's going to be just looking like this. It's just going to be a horizontal line, okay, where this one is 1. Okay, so don't get confused with x equals to 1 and y equals to 1, okay? Y equals to 1 is horizontal. Draw your vertical line and you can clearly see there's one point of intersection, therefore it is a function. So I hope you're getting really used to this now. This should be quite easy after we've done several questions. Okay, let's go to G. This time x equals to -1. If x equals to something, it's a vertical line, where this one is -1. Okay, so label them. And now I'm going to use my vertical line test. Let's put a vertical line through that line. You can see that the vertical line covers that line, or is totally on top of that line. And some of you think that there's only one point of intersection, but actually there's infinite numbers of intersections, right? Can you see that everything on the line is on that vertical line? So therefore this time there are infinite number of intersections, not just 2 like we had in the previous one. There's infinite numbers of intersections, so this is definitely not a function. Okay, please don't get confused with this one. Some people say this is one intersection, but this one is not a function. Okay, there's so many intersections. Okay, that was G. Now with H, y equals to 2 to the power of x. This is an exponential, isn't it? So that looks like this. Okay, now if I put x equal to 0, 2 to the power of 0 is 1, so you might like to label that as 1. And I'm going to put my vertical line there, and you can see that there's one point of intersection. So this one, easy, is a function. Okay, so there's only one point of intersection, so it is a function. Okay, let's go on to I. Y equals to negative x minus 1 squared. Now it's negative, so it's going to be an upside down parabola. Okay, and because it's minus 1, it's going to shift to the right by 1. So it's going to look like this, isn't it? And again, simply put in your vertical line, and I'm going to circle that. One point of intersection, therefore, it is a function. Okay, so that was question 3. I hope that was pretty simple, getting used to it, yeah, because it's just putting the vertical line through the graph. But an important thing here that I'm just worried about is drawing the graph properly. Please be able to draw your graphs properly. In that case, you'll get to the right answer. Okay, so that was question 3.